This video is going to have a look at solving simultaneous linear equations using a graph. So by the end of the video, you'll be able to apply graphical methods to solve simultaneous equations. You will also be able to go ahead and check your solution using substitution. So simultaneous linear equations are a set of equations that can be solved together. They often represent practical problems where you have two or more unknown variables. So one way of solving them is by graphing the two linear lines. Well, after you've graphed the two linear lines, the point where the two lines intersect will be the solution. So the coordinates at the point of intersection are the x and y values that satisfy both the equations. So the x and y value will be the same in both situations. If two linear lines do not intersect, means there is no solution to the equations. So there's no value where their x and y are equal to the same amounts. When looking at linear equations, the only situation in which the lines do not intersect is if the lines are going to be parallel. These lines have the same gradient but different y-intercepts. So that's the only time where you won't have a situation where you can find a solution to the simultaneous equations. So let's have a look at an example. In the first example, we want to identify the coordinates at the point which simultaneously solves the two equations in the graph below. So in the graph, we've got a line that is y equals x plus 3 and a line that is y equals 3x plus 1. And we want to calculate what is the x and y value that those two equations equal the same. And then after we've identified that, we want to check using substitution that the solution is correct. So to identify the solution to the simultaneous equations, we want to identify where the 2 points meet on the graph. And we can identify that by having a look at the graph and just seeing where the two equations meet. And they meet when x is equal to 1 and y is equal to 4. So the solution to the equations is going to be 1 and 4. So now I can go ahead and check my solution by using substitution. The steps to use substitution to check the solutions are going to be write both equations, substitute in the intersection coordinates, so x is equal to and y is equal to, and you substitute them into both equations. Then you want to solve the left-hand side of the equation. After you've substituted in the coordinates, solve the right-hand side of the equation. And then after you solve the left and the right-hand side, check that all sides equal each other. So going back to our example, we want to check that our solution of x is equal to 1 and y is equal to 4 is correct. So step 1, we're going to write both equations. So y equals x plus 3 and y equals 3x plus 1. Now we want to substitute in our value. So x is equal to 1, y is equal to 4 into both equations. So my first equation is going to be 4 equals 1 plus 3. And my second equation is going to be 4 equals 3 times 1 plus 1. So now I want to solve the left-hand side of my equations. So left-hand side is equal to 4, left-hand side is equal to 4. So solving the right-hand side of my equations. So for the first equation, right-hand side is 1 plus 3, which is equal to 4. For the second equation, the right-hand side is going to be 3 times 1 plus 1, which is equal to 4. So the last step, step 5, is to check that all sides are equal, which in this case, they're all equal to 4. So the solution is correct. Look at a second example, and we want to solve the simultaneous equations of y equals 5x plus 2 and y equals 2x minus 3 graphically. So first we need to go ahead and graph each of the equations. So we'll do the first equation, so y equals 5x plus 2. I'm going to graph them using the intercepts method. So calculate the x-intercept when y is equal to 0. So my x-intercept is going to be negative 2 over 5. Then calculate the y-intercept. So when x is equal to 0, y is going to equal to 2. So my intersection points are going to be -2/5 and 2. So graphing 2 and -2/5 and drawing a straight line. So next, I'm going to do the same thing for the second equation. So y equals 2x minus 3. So calculating my x-intercept when y is equal to 0. So my x-intercept is going to be 3/2. Calculating my y-intercept when x is equal to 0. So when x is equal to 0, y is going to equal to -3. So marking in my y-intercept of -3, my x-intercept of 3/2, and drawing in the equation. So now that I have got my two lines drawn, I can go ahead and find the point where they intersect and write down the coordinates. So the point in which they intersect is going to be -1 and 2/3 and -6 and 1/3 for my y value. So that is my point of intersection. So even though the question doesn't ask, we can also go and check using substitution. So substituting our values of -1 and 2/3 and -6 and 1/3 into the equations to check to see whether our solution is correct. So starting off with writing both equations, y equals 5x plus 2, y equals -2x minus 3, then substituting in our x and y values into the equations, having a look at our left-hand side and sides and solving. So left-hand side of the first equation is equal to -6 and 1/3. Left-hand side of the second equation is equal to -6 and 1/3. So step 4, to solve the right-hand side of the equation. So for the first equation, it's going to be 5 times -1 and 2/3 plus 2, which equals to -8 and 1/3 plus 2, which equals to -6 and 1/3. And solving for the second equation, so 2 times -1 and 2/3 minus 3 equals -3 and 1/3 minus 3, which equals to -6 and 1/3. So check that all sides are equal to each other, which they do, which means our solution is correct. So there were a couple of examples of how we can solve simultaneous equations graphically and then use substitution to check our solution.